Alright, today we're going to look at MSM 131. Okay. Tutorial sheet 4. Right, so that's what we're doing today. Tutorial sheet 4. Alright, so that's how we've looked at polynomials. That's what we were looking at last time. Alright, so we want to do a build up on that. Okay, basically that's what we'll be looking at today. Just building up on that. So let's look at tutorial sheet 4. Okay, so basically tutorial sheet 4 is more on binomial. Alright, it's more on binomial. That's what we're going to do, a bit of binomial and a bit of matrices. Okay, so that's where we are getting to. Okay, so what we need to know is whenever we are dealing with questions of this nature, all right, whenever we're dealing with questions of this nature, we first need to understand what n factorial means, right? So whenever you see n factorial, it means n minus 1, n minus 2, n minus 3, and so on up to 1. Right? So this is what n factorial is, and that's what it stands for. So if you get to understand that, then you'll be able to apply that with questions that relate to it. All right. So basically speaking, if you look at n factorial, let's say you've been given 7 factorial. Okay. So 7 factorial would be 7 times 6 times 5 times 4 times 3 times 2 up to 1. Right? So 7 times 6 times 5 times 4 times 3 times 2 up to 1. Right? So basically that's what the factorial means. Alright? Now, what it is that whenever you see the factorial, as I said before, it's n multiplied by the one before it, multiplied by the one before that one before. So it's we're subtracting a 1, right? It's like we're subtracting a 1 from all of them. So you can actually not always end at 1, okay? For instance, this very 7 factorial can also be written as 7 times 6 times 5 factorial, all right? So you can end at 5 factorial, but what it means is that when you end at 5 factorial, you have to always remember that the 5 simply means you're still moving down to 4, 3, 2, and 1, right? So that's how it works. Okay, so whenever you see the factorial, it means the numbers are still moving down until they reach 1. But there are some certain instances, especially whenever we're applying it to the binomial, where we really do not need to expand throughout up to reaching 0. Alright, so this is why you notice that usually we don't go as far as reaching 0. Right? So an example is if you are given, let's say, we have to know what the definition of n choose r is, right? So n choose r is n factorial over n minus r factorial r factorial, alright? So usually we are applying that from this formula. Let's say you've got 7 choose 3, right? So say in this case 7 choose 3, 7 is your n and 3 is actually your r. So we're going to say 7 factorial over n minus r, so it's 7 minus 3, which is 4 factorial, then 3 factorial, alright? So this is what we have. But we can write 7 factorial over 4 factorial, 3 factorial as 7 times 6 times 5. I'll end up to 3, right? Okay, I'll end up to 4 factorial. So we usually end at the largest in the denominator. So in this case, the largest in the denominator is 4 factorial, right? So I'll end at 4 factorial. So this is over 4 factorial, 3 factorial. You understand why I've done that? So that this and that can cancel. Okay, so the 4 factorial and the 4 factorial in the denominator and numerator will cancel. So we now have 7 times 6 times 5 over 3 factorial is 3 times 2 times 1. Alright, so 3 times 2 is 6, so 6 and that will cancel. So this is basically 35. Okay, so this is what you have. 7 times 5 is 35, all right? So that's how we deal with the factorial. That's how we deal with the factorial. Okay. That's how we deal with the factorial. All right, so let's continue with the actual questions in question, all right? Let's look at the actual questions. So let's okay. So usually if you are not able to see, just change your video quality to 720, right? Change your video quality to 720. Alright, so the first question says evaluate. The first question says evaluate. Evaluate 15 factorial, part 1. So you have 15 factorial over 12 factorial, right? So you've got 15 factorial over 12 factorial. How do you evaluate that? Right, so as I said before, what we are going to do is we're simply going to end at the largest in the denominator. In this case is 12. So it's 15 times 14 times 13 times 12 factorial. Everything over 12 factorial. So you notice that the 12 and the 12 will cancel, right? So this is what we have. So now we are simply multiplying 15 times 14 times 13, which is 2,730. So that's your answer, 2,730. Okay, so that becomes your ultimate answer, 2,730. Okay. Right, let's build up from there. I'll do a different set of questions. So I cannot do so many questions because I want to tackle quite a lot of things. Alright, so the next question says, 9 factorial over 9 factorial over 2 factorial, 3 factorial, 4 factorial. Okay. Okay, so how do we answer this question? To answer this question, we're simply going to end at the largest. So we have 9 times 8 times 7 times 6 times 5 times 4 factorial, right? Over 2 factorial multiplied by 3 factorial multiplied by 4 factorial. So this and this will cancel. Now remember that 3 factorial is 3 times 2, which is 6. So 3 factorial and 6 will cancel. And 2 factorial is just 2 into 8, that's 4, right? So you end up having your final answer as 9 times 4 times 7 times 5, which is 1260, right? So that is your answer, 1260. Right. That becomes your final answer, 1260. Alright, so let's look at B. Let's look at B. Let's look at B. Okay, before we, let's look at B. B says, write the following in factorial form, alright? So write the following in factorial form. I'll just do this one, m plus r minus 2 minus 1 m plus r minus 2, alright? So if you look at this, ladies and gentlemen, what you notice is that the n is constant, but what is changing is the r. It was r, now we subtracted the 1, we subtracted the 2. So what do you think the next will be? It's supposed to be r minus 3. Okay, so it's n plus r minus 3. That's the next one. After that, n plus r minus 4. Alright, so now since we need to write this in factorial form, alright, we are going to divide whatever is supposed to follow from here. Okay, so n plus r minus 2, what follows n plus r minus 2? It's n plus r minus 3. So that's what we're going to divide by, alright? So we're going to say, we're going to write this part here as n plus r factorial. So it's going to be n plus r, then factorial, then over. We're now going to divide what comes after this one. So it's n plus r minus 3. Okay, so factorial, like that, right? So this is how you write it in factorial form. You always just follow the one that comes after the last one. So you write the first one factorial, the first component factorial, then over the last one, the one that follows the last one. All right, so that's factorial. That's how you write it. If you are to change this into factorial form, the next one will be n plus r minus 1, then after that n plus r minus 2, then n plus r minus 3 factorial. So this one and the 3 factorial will cancel. What will remain is what you have in your numerator there. Alright, so that's how you deal with those questions. Alright, so that concludes it. Maybe let me do the next one, which is part 3. Alright, C. So you do part 3. I've shown you how to do the other one. So part 3 is similar. So the first one there is n. So it's going to be n factorial over. Now you will notice that 4 times 3 times 2. Let me write that. So this one is going to be n factorial over 4 factorial, then n minus 3 factorial. Right? So if you check, you find that the first one is n, so the first factorial over the one that follows the last one, which is actually n minus 2, so the one after n minus 2 is n minus 3. So it's going to be over n minus 3 factorial. Now the 4 times 3 times 2 times 1 is just 4 factorial, so this is why I've written it as 4 factorial. Alright? So this is how you deal with that question. Let's go to C. You should try part 1 and part 3, right? For those that want, we can actually verify your solutions, right? We can verify your solutions. Okay, so C says factorize completely the following, right? So factorize completely. C, I'll just do part 2. Okay, so C part 2. Part 2 says n squared. You have n squared, n minus 1 factorial plus 2n, n minus 2 factorial, right? So basically this is it's a similar concept, right? So it's a similar concept, so I'll do the same parts 2. Right, so I'll do parts 2. If you look at part 2, you just follow what is common, right? So if you check, right? If you check, this one is ending at n minus 2 factorial, so I can actually write that as n minus 2 factorial. Alright, so this n minus 1, I can say this is n squared, n minus 1, then n minus 2 factorial, right? Then plus 2n, n minus 2 factorial, right? So this one I've just taken it to the next term, right, which is n minus 2. So that now we have what is common as n, alright? So n is common from both, and we also have n minus 2 factorial is also common. Then what remains from here, it's n minus 1, right? Then we have plus 2, right? So that's your answer right there. So that's basically what we have. So I've just factorized. Here what I've done is I've factored out the n and the n minus 2 factorial because it is common to both, alright? Then we have n squared, then we have 2n, so meaning there's an n here, there's an n here, which are factored out. So that's basically how you go about these questions, alright? So it's not as complicated as it looks. It's just the general concept which you need. Once you get hold of the general concept, I think the rest should be quite straightforward, right? So once you capture the concept, then the rest should be straightforward. Okay, so that's how we do all those questions. Next up, let's look at the next question. Alright, so the next question okay, so on the next question, let's probably look at D, right? So let's probably look at D. Let's look at D. Okay, so what is D saying? Okay, so I'm sure by now you must have attempted some of those questions this time of Okay, so let's maybe look at something that is more complicated than that. So we have n factorial r squared Okay, so that's the question that we're looking at now. Right, so first thing first, we are going to check what is common, then from there we'll be able to know what we can easily factor out, right? So we're going to check for what's common. So if you look at that, you notice that you have n minus 1 factorial in the second part of the numerator here. So meaning this one can be written as n minus 1 factorial, right? Then you also have r minus 1 factorial from here, and you have r factorial from here. So meaning you can write r factorial from here as r minus 1 factorial. Alright, so we can actually write it in that form. Okay, so that we can easily factor out what is common, right? So you notice that, as I said, what you now have, you have this as n factorial r squared. So let's write this n minus 1 factorial, so it looks like that now. Then we have r squared minus 2, then n minus 1 factorial. We maintain that, right? Then from there, what we now get is, in the denominator here, you notice that r factorial is can be written as r minus 1 factorial. So you have n minus 1 factorial, then r minus 1. So it's r multiplied by r minus 1 factorial. Remember that the factorial means the one you're starting from minus the one that comes after it. Okay, so the one you're starting from, then minus the one that follows it, just like that. All right, so meaning that r factorial can actually be written as r minus 1 factorial. All right, so this is why I'm writing it as r minus 1 factorial. All right, then okay, so from here, then what we will have is over r minus 1 factorial n minus r then factorial. All right, so this is basically where we are going to. All right, from here what we can do now is we can factor out what is common, right? We can factor out what is common. So if you notice from the pictorial point of view, what you have which is common there is basically n minus 1 factorial is common, right? Then you also have n minus 1 factorial, so you can factor out n minus 1, right? Then factorial, because it's common, right? Then in the denominator, what is common? So in the denominator, what is common? In the denominator, what is common? We have this is actually n minus r from the question. Let me just verify it. Right? Let me just verify it. Yes, this is actually r here, not 1. It's n minus r, right? So you have n minus r here, n minus r there. Alright, so n minus r is common and r minus 1 is also common. So you have n minus r, then you also have, this is factorial, then you also have r minus 1 factorial, right? So what remains on this side will be n r squared over, then in the denominator you're going to have r there, then minus, on the other side you are remaining with just 2, alright? So on the other side you're just remaining with 2 because I factored out with both of these. So from here you have minus 1, alright? So this r here can go into this one, so basically speaking, your final answer ends up being n minus 1 factorial over n minus r factorial, alright, r minus 1 factorial multiplied by n r minus 2, right? So I factorize that, so basically that's how you factorize it, okay? So that's how you factorize that particular one. Okay, so just that, nr minus 2, right? Question 2. Let's look at question 2 now. Alright, so what is question 2 saying? What's question 2 saying? Alright, so question 2 says find the term independent of x and the expansion of x minus 1 over 2x squared to the power 9. Alright, so how do we find the term that is independent of x? To find the term independent of x in this expansion, we'll use the formula for n. The general formula for the r plus 1th term, alright? So the general formula for the r plus 1th term is found as n choose r, then a to the power n minus r br, right? So this is the general formula for the r plus 1th term, alright? Now, you've been given the question as x minus 1 over 2x squared to the power 9, right? So this is what you have there. So now we want to know what is the term independent of x in that expansion. We want to know the term that is independent of x in that expansion. So to get to the term independent of x in that expansion, what we are going to do is we're going to identify the n. We're going to identify the n. Then apart from identifying the n, we are also going to identify the a and the b. Alright, so this is a, this is b, and this is n. Alright, so now what you've been told that the term independent of x. Alright, so let's write that first as 9 choose r. So 9 choose r because we don't know what the r is, alright? Then a is x, right? Then 9 minus r. Then we have negative 1 over 2x squared to the power r. Alright, so I've just replaced the components. I've replaced a, b, and c in that question. Alright, so I mean a, b, n, I've replaced them, but we don't know what r is. Remember, we're looking for the term independent of x, so we don't end there. Alright, so what we do now is we know that for the term to be independent of x, then the x should be to the power 0, right? So what we'll do is we'll just collect the part which contains x, right? So we have x to the power 9 minus r, right? Then it's being multiplied by, if you write this, this is going to be the same as divided, right? Okay, let's first distribute this for the sake of someone. So this is the same as negative 1 to the power r over 2 to the power r, then x to the power 2r, right? So basically this is what you get. So you are saying 2 to the power r, then x to the power 2r. That's what you have there in the denominator. So that's what we have in the denominator, and we're looking for the term independent of x, right? So if it's not so visible, this is 2r, right? So that's 2r there, right? Then from here we are going to collect only the part that contains x, all right? So I'm just looking for the part that contains x. So what we're now saying is that what we're going to have is x, maybe here, x, right, to the power 9 minus r, right, then multiplied by, if the x in the denominator comes in the numerator, this is negative 2r, not so. And this should be equals to x to the power 0, meaning that whatever the multiple of these two is, should end up being having a power of 0. Why? Because we are looking for the term independent of x, meaning whatever, when x is raised to the power 0, it's 1, so it has no x in it, alright? So what I've done here is that the x to r was in the denominator, and we know that if you wanted, you could have written this as over x to r, alright? So that we know that division of same bases is the same as subtraction of powers, but as I said, this should be still equal to the x to the power 0. Right? So division of the same bases is the same as subtraction of powers. So we have x to the power 9 minus r minus 2r is equals to x to the power 0. So it should give us x to the power 0. Right? So that should be the end result of what we have. Alright, now we know that these are like terms, so you have 9. If bases are the same, meaning powers are the same, so 9 minus 3r is equals to 0, right? Then we have 3r is equals to 9 over 3 over 3. So the r we are looking for is basically 3, okay? So the r we are looking for is 3. Now that we know what our r is, we're now going to use this 3 to replace it in there in order for us to find the final answer, alright? So we're going to replace the 3 wherever there's r so that we find the final answer, okay? So let's write it from this side, right? Okay, so basically what we're going to have now is 9 choose 3 from there. So we have 9 choose 3. Then we have x to the power 9 minus 3. Then negative 1 to the power 3 over 2 to the power 3, x to the power 2 times 3 is 6. Alright, then we have 9 choose 3, x to the power 9 minus 3 is 6. Then we have negative 1 over 8, because we know 2 to the power 3 is 8, and x to the power 6. So you notice that the x to the power 6's will cancel out. So the x to the power 6's will cancel out. Then what you get now is 9 choose 3. So what is 9 choose 3? So 9 choose 3 is the same as 9 factorial over 9 minus 3 is 6. So 6 factorial, then 3 factorial multiplied by negative 1 over 8. Alright? So you can finish that up. Right, so 9 factorial over 6 factorial, 3 factorial, negative 1 over 8. So that's basically what you have as your final component. Alright? So that's what you have as the final component. Alright, so 9 factorial over 6 factorial, 3 factorial. Okay. Pardon me, my markers are growing faint. Right, let's look at a different question. Alright, so you should basically finish up that, right? Your final answer should be negative 21 over 2, alright? So this is equal to negative 21 over 2. Negative 21 over 2, so that will be the final answer which you have for that question. Alright, next question. Question 3. Okay. Okay, so obtain the first 3 terms in the expansion of B, so I'll just talk about it, alright. Obtain the first 3 terms in the expansion of A plus x over B to the power 6 in ascending powers of x. If the first and the third terms are 64 and 80x to the power 2 over 3 respectively, find the values of A and B and the second term, alright. Basically speaking, you've been asked for the first 3 terms in that expansion. Okay, so I'll do question 3 instead. 3 says expand 1 plus 2x to the power 5 and 1 minus 2x to the power 5 in ascending powers of x. Hence reduce 1 plus 2 to the power x to its simplest form. After that, we need to use the results to find 1.002 to the power 5 minus 0.998 to the power 5. Right? So question 3. All right. All right. So question 3. You've been given 1 plus 2x to the power 5, right? So we need to expand that. 1 plus 2x to the power 5. Right, so expanding that, I can use Pascal's triangle, right? So if you check Pascal's triangle, which says 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Right, so by Pascal's triangle, I know that the coefficients of a plus b to the power 5 are 1, 5, 10, 10, 5, 1. Right, so this is basically going to be the first term as 1 to the power 5 plus the second term, which is going to be 5 multiplied by 1 to the power 4, then 2x to the power 1. Okay, then plus the next term, which is going to be 10, then the 1 is now raised to the power 3. The 1's power is reducing as the x power is increasing, okay, so in ascending powers of x, so 2x to the power 2 plus, right, plus 10 again, plus 10, then we have 1 to the power 2, then 2x to the power 3, then plus 5, then 1, then 2x to the power 4, okay, then plus lastly we have 1, which is 2x 1 to the power 0, then 2x to the power 5, right? So that's basically what you have as your expansion. So I'm going to write the final result of the expansion on this other side. Okay, so the first 5 terms, when you expand them, what we're going to have is 1 plus 2x to the power 5 is equals to 1 plus 10x, right? Because we have 2 times 5 is 10, so that's 10x, plus we have 10. This is 2 to the power 2, which is 4. Then 4 times 10 is 40, right? So we have 40x squared plus 40x squared plus the next one, we are multiplying 2 to the power 3, which is 8. 8 times 10, which is 80, okay? But we have 80x to the power 3, right? So 80x to the power 3 plus the next one, which is going to be 5 again. This is still going to be 80, because 2 to the power 4 is basically 16. Then we have 16 times 5, which is 80. So we have 80x to the power 4. Then plus lastly, 2 to the power 5 is 32. We have 32x to the power 5, right? So 32x to the power 5. So that will be the final or last part of the solution, 32x to the power 5. Now we've just done one part. The other one we were asked for was 1 minus 2x, alright? So 1 minus 2x to the power 5, right? So this is going to be the same thing. The only difference you'll notice is that this part here now has a negative instead of having a positive, alright? So what you can do simply is, instead of rewriting everything here, you can basically use this. We know that whenever a negative number is raised to an odd power, then it remains negative. If the power is even, then it remains positive. So I'm going to write the exact same thing, but wherever there is an odd power or the odd number, if the power of x is an odd number, right? If it's not an even number, then automatically I conclude that it's negative. So we have 1 plus 10x, right? So yes, so we have 1 plus 10x. Now remember, instead of having 10x, we're going to have minus, right? So in this case, because 2x is negative, so that one is not even, so it becomes minus, right? So minus 10x, then plus 40x squared minus 80x to the power 3, then plus 80x to the power 4, then minus 32x to the power 5, right? So the 32 at the end is minus, because the 5 is not even, all right? So whatever power which is not even automatically becomes a negative, all right? So from here, let's continue on. All right, so from here, the next thing that we're going to do now is we're going to consider what the question is asking us. So we've expanded those two according to the question, but it doesn't end there. We've been told that we need now to subtract the two and write it in its simplest form. So hence reduce, right? 1 plus 2x to the power 5. So we have 1 plus 2x to the power 5 So we have 1 plus 2x to the power 5 minus 1 plus 1 minus 2x to the power 5, right? So this is equal to, so this is basically saying this part subtracting this part, right? So I'm subtracting these two now. I'm subtracting these two. So in doing so, you notice that the minus is on the second. So 1 minus 1 is 0, so the 1 goes, right? Okay. Maybe for the sake of someone, let's write it down. Let's write it down step by step. So what we're going to have now is we're going to have 1 plus 10x plus 40 x squared plus 80 x to the power 3 plus 80 x to the power 4 plus 32 x to the power 5, right? The minus the second part, which is 1 minus 10x plus 40 x squared minus 80 x to the power 3 plus 80 x to the power 4 minus 32 x to the power 5. Alright. Okay, so on subtracting the two, we have 1 minus 1 is 0, okay? Then 10x minus 10x is 20x, so we have 20x, right? Then 40x squared minus 40x squared, that will disappear. Then we have 80x cubed minus 80x cubed is 160x cubed, right? Then we have, remember I'm subtracting, so 1 minus 1 was 0, 10x minus 10x will become 10 minus minus, so it's positive, so it becomes 20x, right? Then 40x squared minus 40x squared is 0, then we have 80x cubed minus 80x cubed, so minus minus becomes positive, so it's like 80 plus 80, which is 160 x cubed, alright? Then we have 80, we have 80x to the power 4 minus 80x to the power 4, so that will cancel out. Then we have 32x, then after that we have 32x to the power 5 minus minus, so that becomes positive. So 32 plus 32 is actually 64, so we have plus 64x to the power 5. Alright, so this is the simplified version of the solution. So we've simplified it as much as possible. That's what we are taught to do. Simplify it as much as possible. So we have basically simplified that. Okay. So we've simplified that. Okay, so what we now have is we've now been taught to find the new question, the answer to the question. So this is basically like the application of the binomial. So that's more or less like the application of the binomial. Alright. So it's as if I'm just applying the binomial. Okay, so on applying the binomial, what we are going to have is let's look at what the question is asking us for. Okay, so hence we've been told to find 1.002 to the power 5. So you have been told 1.002 to the power 5 minus 1 minus 0.002 to the power 5, right? So this can be written as 1 plus 0.002 to the power 5 minus 1 minus, okay, let me just check that. Okay, so it says 1.002 to the power 5 minus 0.998 to the power 5, right? So 0.998 to the power 5. Now, this part is the same as 1 plus 0.002 to the power 5. So what did they add to 1 to get to 0.002? They added 0.002 to 1 to get to this. So what I'm doing is I'm now splitting this so that it looks like a standard form, alright? So I'm splitting it deliberately so that it looks like a standard form. In the same way, we're going to ask ourselves, this number looks like it's less than 1, but what did they subtract from the nearest whole number? The nearest whole number is 1. Alright, so if you subtract 1 minus 0.002, you get 0.998. So meaning this one actually is 1 minus 0.002, then to the power 5. Alright, if you subtract 1 minus 0.002, you get back to this. If you add 1 plus 0.002, you get back to this. Alright, so I've deliberately written it like this so that it looks like standard form, alright, in the binomial expansion form. Then from here, what we get now is we're going to have we're going to have this same thing here, and now going to write it as 1 plus, I'm going to factor out the 2, then you notice that we have 0.001, alright? Then the power 5 minus, even here I'll factor out a 2, you have 0.001, the power 5, alright? So you have 0.001 to the power 5. Now it looks exactly like the one that we expanded. So if you compare this one and this one, look the same, right? So if you compare the two, you notice that this one and that one looks the same. So what is your x? So in that case, since this is 1, this is 2, right? This is 1, this is 2, and this is 5, this is still 5 and 5. So meaning that the x here is actually represented by 0.001. So the x is being represented by 0.001. So meaning that wherever there is x in here, I'm actually going to put 0.001, right? So wherever there is x, I'll put 0.001. So doing that, we have 20, open bracket, 0.001 plus 160, open, 0.001 square to the power 3 plus 64, open, 0.001 to the power 5. Alright? Alright, so that's basically that. Now, you can change this back to, if you want, you can write this as a fraction. So that's 1 over 1,000, alright? This is 1 over 1,000. So 0.001 is the same as 1 over 1,000. So you can write it as a fraction if you want. But note that if you write it as a fraction as 1 over 0.1 over 1000. Then what you have here is 1 over 1000 to the power 3, alright? That's like, you're now having 3 1000s. So multiplying 1000 times 1000 times 1000, which is going to be 1 billion, alright? So that's what we're going to have. So it's going to be 160 over 1 billion, alright? So you can write that in form of a fraction. You can write that in form of a fraction. Alright, so you can write that in form of a fraction. So this is a 3 here. Alright, so basically your final answer, remember you're not allowed to use calculators. Alright, so you're not allowed to use calculators, but as I've said, convert that, you can convert that to fractions, or if you want, you know that 0.001 to the power 3, these zeros here, okay, will just reappear about 3 times. So you have 0, 0, 0, 0, 0, 0, then you have 1, right? In the same way, these zeros will appear, the 2 zeros will likely appear 5 times. So 2 zeros 1, 2 zeros 2, 2 zeros 3, 2 zeros 4, 2 zeros 5, then 1. Right? But basically speaking, it's easier if you write it in form of a fraction as 1 over 1000. Then from there you raise 1000 to the power 3, okay, which is basically going to be, as I said, 3 million. Alright, we're going to have 1 billion. Then the other one there, you raise it to the power 5. So you repeat the 3 zeros quite about 5 times. Alright, so that's what you are going to do. Okay, so basically speaking, what you have now. So if you do that, right, let me write it for you. So this is the same as 20 over 1000, right? Then we have plus 160 over 1000 to the power 3, you have 1 billion, as I said. You have about 9 zeros, then plus, then you have 64 over, so there are 3 zeros, those 3 zeros are going to appear 5 times, right? So you have 1 over 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, so 1, 2, 3, 4, again 5. Okay, it's quite a large number for me to mention. Alright. Okay, so basically this is how you narrow down your zeros. So if this is 1 over 1000, if you raise it to the power 2, so these 3 zeros just come 2, so it's 1 million, alright? If you raise it to the power 3, the 3 zeros will appear 3 times, alright? So it will be 3 zeros 1, 3 zeros 2, 3 zeros 3, alright? Then if you raise it to the power 4, how many 3 zeros are you going to have? You're going to have 4 3 zeros. So you're going to have the first set of 3 zeros, the second set of 3 zeros, the third set of 3 zeros, and the fourth set of 3 zeros, alright? Then if you raise it to the power 5, you're going to have 5 sets of 3 zeros, alright? So you have the first 3 zeros, the second up to the fifth 3 zeros, okay? So if you have 1 over 100, 1 over 100, so if you raise 1 over 100 to the power 4, so, or maybe to the power 3, alright? So you're going to have the first 2 zeros, the second 2 zeros, the third 2 zeros, so which is basically going to be about 1 million, right? So since you've got 6 zeros, okay. So the final answer to that ends up being so 0.020 plus, that one is 160, so we have 1, 2, 3, 4, 5, 6, right? 160 plus then we have that's 64. So we're going to have these are points, by the way. You've got decimals there. 0 point, right? So you've got decimals there. So 0 point, 6 zeros before the ninth one, then plus 0 point. So now here when you know that you have 64. So 64 has got that's like 2 digits or 2 decimal places, alright? So meaning that it's going to occupy the last 2 zeros in that denominator. So we are going to have the denominator as, so, alright, plus the denominator will be 0.1234566. Alright, so 1, 2, 3, that's supposed to be 5. So 1, 2, 3, then we have 4, then we have 0, 6, 4. That's the fifth one, right? So if you add those three, they're going to have 0.020, 0, 0, 0, 160, 1, 2, 3, 4, 5, 6, 4. Right, so that's the final answer to that question. That's the final answer to that question. Let's see if we can make it more visible. Okay, so basically that's the number I've written there. Alright, so with that's the end of our tutorial this morning. Have a good day.